Invicti Security presents AppSec Serialized, a podcast about web security and those who practice it. Episode 3, APIs Wide Open. Mallory yawned and stretched. She had dozed off in her chair as Pac-Man finally finished updating the packages on her Arch Linux system. Fully patched and upgraded, she checked out the latest info that had shown up in the private Helifam channel that she shared with her inner circle of friends and hackers. One of the newest members had offered up hot breach data. The new guy was just looking to establish a reputation. She was pretty sure he was a contractor who worked for like 100 companies with super limited permissions and passed off the weak stuff to which his gig work let him have access as evidence of his godlike application of 0 days. Even the name of the file was pretentious, Cygnus X1.7z, named after a black hole, probably implying supermassive amounts of data that had been vacuumed up. It was probably not interesting at all. Still, she had a quick peek at it. After decompressing the LZMA archive, she saw it was just Nginx logs, the records of run-of-the-mill HTTP requests like security cam footage from an unknown convenience store. Pretty dull stuff. But wait, there was something interesting in the data. Unlike most web server logs, these were from an instance of Nginx that had HTTP header logging turned on. She sat up straighter and fired up ripgrep to search the thousands of files from a particular HTTP header, one called authorization, and there it was, hidden in the millions of lines of logs, a single GET request to an address she pulled from the host header to a business-to-business API endpoint. On a whim, she base64 decoded the blob of the authorization header to obtain the credentials and ran a quick curl command to the same location. She tapped the shift key of her keyboard impatiently, waiting for the query to resolve. A sharp intake of breath, the creds were still good, and the Cygnus X1 server was on the edge, facing her, facing the world. It looked like this was some kind of business-to-business integration. The JSON blob was pretty boring and looked like QA test data. It had a webhook URL and an API key field. Thinking that this may be a thread that led to a new system, she tried to access the new URL, putting the API key into a few spots. Nothing. The URL looked faked anyway, probably old test data. Her mind went back to the URL, which ended in B2B/5. That last path element, could that be a monotonically increasing integer, a simple ++ on the back end? She tried it out and changed the URL to B2B/6 and got back different data. This looked like a classic insecure direct object reference. The code on the other end was expecting a polite and demure API client that would only request the entities to which it had access. Mallory was anything but polite and demure. She hopped back on Helifam to see if anyone had a tool for this. Sure enough, there was one. A tight little program written in Go called Idoru. Gibson reference. Heh. She ran it. There was dead space up until she started to hit 6-digit numbers. But at B2B/100,001, she found real data, leading to a webhook URL to a company called MegaHelix on some server named Galactus v2020, which looked old and musty. And there were credentials with which to call the MegaHelix API. There was no way this was going to work. She did a simple GET to that URL. 404, not found. But it was not a 403, an access denied that would have been game over. On a whim, she removed the path and hit the root URL. And there, before her, she had it. A full map of an exposed API, a Swagger file, the full blueprint to this abandoned, unsecured building. She quickly opened it up in Postman and looked at what was there. A low, breathy whistle escaped her lips. The endpoints had names like credentials, payment, batch job PowerShell params, AWS secret access keys, SSH files, custom JavaScript blobs, and more. She pounded an ecstatic staccato rhythm on her Control and Alt keys, the Cherry MX Blue switches of her mechanical keyboard dancing in perfect synchronicity with her rapid pulse. It was going to be a long and very fun night.
Welcome to another episode of AppSec Serialized, the podcast where we talk about web app and API security. My name is Frank Catucci. I am the CTO and head of security research here at Invicti Security.
And I am Dan Murphy, the chief architect here at Invicti Security.
Our topic for today, API. We're going to dive into the world of API security.
And Frank, APIs are a major concern these days. They are the secret door through which a lot of attacks are perpetrated. What are some recent attacks where the attacker has gained access to a system through the door of an API?
There's quite a few to choose from, Dan, but I always like to start with the one that's almost the most in your face as of recently, and that's the Optus API breach.
Oh, yeah. Yep.
So attackers essentially discovered a publicly exposed endpoint. But what was more impressive about that publicly exposed endpoint is that, one, it didn't require any authentication methodology at all. So there was no authn or authz tied to that endpoint. And what that endpoint had access to. So that endpoint had access to sensitive customer data, anything from driver's license numbers, date of birth, home address, phone numbers, any personal identifiable information that you could possibly imagine. But beyond that, it was also the scope, right? We look at this, and I think I want to say the numbers were somewhere just shy of 12 million customer records for personal identifiable information that were all just sitting there ripe for the plucking without any authentication or authorization, sitting in front of a publicly exposed endpoint. We're talking hundreds of millions of dollars in damage just from the Optus breach, which was very, very, very widespread. And the impact of the user base, especially if you look at all of the customers that Optus had, was just massive reach. That's just the Optus one.
Yeah, and this is an example of an operation where you have a bank vault. You have like this heavily policed exterior because no one's going to put something on the edge with no authentication. But this was a gap that was what they call a shadow API, something that is there that anybody who really knew would know instantly by looking at it that it wasn't appropriate to have this right next to the bank vault door, have the wide open archway with a turnstile you could just walk right into. And those shadow APIs, they're a real concern.
Oh, absolutely. And then we have a lot of different types of breaches that have occurred with multiple different types of attack vectors, right? So another one that I like to look at is what happened to Dropbox. I believe this is about a year ago or so, maybe a little bit more than a year ago. But essentially, attackers were able to have access to Dropbox internal code repos. Essentially started with a phishing attack. However, that phishing attack ended up resulting in access to over 100 internal repos. What was in those internal repos is API keys, right?
Yep. Yeah.
Once we got that far, where we're having the API keys in your hands, especially from internal repositories, we know which is pretty much anything on those APIs is going to be able to get accessed. And you're using legitimate credentialed type of access or authentication with those keys to be able to grab that information. And this, this one in particular utilized a couple of different things. Sure, there was a phishing mode of entry. However, where the data was exfiltrated from, 100% were the APIs and those API keys that were actually stored along with the user data in some of those internal repositories.
And it's kind of interesting because one of the things that, I come from a software engineering background. And so to me, an API is like a very natural thing. But for folks who don't necessarily come from that background, it's sometimes hard to kind of visualize, what is an API? How does it differ from a web app? And the answer is that, those things are a little bit blurred. A lot of modern applications are single page applications that are simply invoking APIs as part as they click around. But one of the metaphors that I like to use is that APIs are almost like they're the internals of the web app. They don't have a GUI. They don't have kind of something that you can see and touch and feel. They are the service elevators. They are the high capacity ways to get up the skyscraper that no one who's coming in the front door sees. And it's pretty easy to forget about them. But they lift up a lot of cargo, and a lot of stuff goes up those service elevators. And much in the same way with a real physical building, you never see it. So you don't necessarily know that it's being cleaned, that it's being kept up to date, that it is passing all of its service maintenance checks. In fact, it's pretty easy for an API, which doesn't have an end user visible manifestation, to kind of be ignored, to go out of date. You and I, we can kind of go to a website, and much like our predictive risk technology, it takes a look at like a website and says, does this look kind of sketchy? APIs are a lot more difficult to do that kind of quick 2-second analysis on, because they don't have anything that you can touch. They don't have anything you can see. They don't have anything that you can feel. They are really kind of like a catalog of operations, of invisible operations that could be performed on a computer, right? So they are like a list of endpoints, right? And all of those endpoints are composed of a path and like an operation. REST is probably the most popular type of API, and you might have different things that you could do on an endpoint, like /users. You might want to create a new one by doing a post to /users, get the information for a user, maybe by putting in their telephone number and getting back their social security number, like the example you had earlier, where you do a get users / and then, their phone number or something like that. A delete operation, a patch operation, it goes on and on. But all of these things, they're kind of out of sight. They're out of mind. And they're built to operate in bulk. So they're often, like that service elevator, they're lifting up huge amounts of tonnage, sometimes millions of interconnected systems that are just chatting to each other without kind of like a human watching and a human saying, oh, look, this looks visually dusty. This looks like it's out of shape. The robot is riding that elevator. And so it's pretty easy for them to become invisible. And when something is invisible, well, it can be a source of attack.
You made some good points there. When we're looking at different types of like vulnerabilities, like I have an OWASP top 10. I know what, my web application may or may not be susceptible to X. If we look at the last one I want to talk about is Zendesk. If we take a look at that breach that occurred, we had essentially a GraphQL endpoint that had a vulnerability. That vulnerability in that GraphQL endpoint happened to be, ready for it, SQL injection. This is something that we would traditionally associate with a web application, a traditional SQL injection that has been occurring since day one of SQL databases used to populate data queries from any type of web application. However, this one was a GraphQL endpoint that had a SQL injection. That vulnerability basically allowed criminals to get access to all of customers' conversations, email addresses, ticket numbers, and sensitive data in those support tickets on other customer sites that were using Zendesk, right? So these are things that you would traditionally associate with a web application. And where really I was going with this, beyond that breach, Dan, is, we talk about the differences, right? Key differences. You mentioned scale, those elevators and things, but how would, if you were talking to a user about security of web apps and APIs, like what are the main, maybe technical or architectural differences between APIs and web applications?
So if we ignore for a second kind of the single page apps that are kind of a hybrid between the two, with a traditional API, the user agent, the thing on the other end, is not the web browser. It's a piece of code. So it's going to be something. Maybe that's some other web service invoking a webhook, or maybe that is some back-end code or systems that are talking to each other. But it's not someone clicking and sitting inside of a browser. The rise of APIs kind of historically grew out of the code that would execute when you submitted that form way back in the day. That code that does something when the user puts in a bunch of input is kind of what grew into APIs. Nowadays, it's very kind of in fashion to style big systems as a series of smaller connected Lego blocks that talk to each other over an API. But the key difference is that it's not a browser on the other side. But like you said, it's still code. So all of the classic vulnerabilities, it's still possible to have code evaluation if you don't sanitize the inputs and you've got an app on the back end that's written in Node that evals some of the inputs. Well, the same vulnerability that you can find in a web app, you can find inside of that back end. Now, of course, that's not true for everything. There's going to be certain classes of things that are attacks that are very specific to a web browser, things like, clickjacking or cross-site scripting that requires a JavaScript engine in which to be executing. But there's still a lot of very high severity attacks that the same sort of ways that a bad guy would exploit and do SQL injection in the back end, the same thing it holds true for APIs. And sometimes we forget that. And it goes to that out of sight, out of mind property that I alluded to earlier, where it's all code on the back end. And that code can have many of the same vulnerabilities that a traditional web app could have. And Frank, I actually have a question for you, right? So sure. We talk about APIs, and we talk about like how companies have sometimes a lot of these APIs. What are some of the existing mechanisms that companies use to kind of organize and keep track of all the gaps that they have on their edge? Like where do people hold all of these APIs?
One of the things that you mentioned earlier was the amount of lift that these APIs are designed to do. So we look at the ability to do things like rate limiting, et cetera, for these type of attacks on something that's made to essentially deliver a large amount of information or data. Now, this gets to the next question that you just asked me: is where can we keep that information? Where do we basically have a good idea or understanding of where that lives? Well, we can do a couple of different things in the same place. We can utilize some security pieces of these existing solutions. I look at API gateways to have almost be like a pared down, simple format Swiss Army knife for APIs, if you will. So we look at things like the AWS API gateways, MuleSoft, Apigee, using specific formats like OpenAPI, Swagger, etc. But within these gateways, we have the ability to do a lot of different things. We can not only keep an inventory of our APIs and know what exactly exists, but we also can control those APIs in a number of different ways. API gateways are really good at formulating some type of control, whether it's a authorization or authentication type of entrance point. They also could have specified gates of rights, almost like a, let's say, a operationalized form of RBAC, if you will, that could occur at the gateway level. There are also some API gateways that do security procedures, right? They function as a security beacon or a security sentinel that would allow the additional insight into those. There's also micro gateways that do internal east-west traffic for APIs. There are ways to set up complex API gateways with external or public APIs and then east-west internal APIs, and then maybe making sure that the tokenization that's used is terminated and reestablished for a public API that does have to talk to an internal API before it feeds data back. So there's a lot of like advanced configuration and precautions that can go into those organizational or inventorial different pieces of API management. We talk about specs, right? These can live in various formats, like I mentioned. But there's also informal specs, right? There's things that are beyond using OpenAPI or Swagger. You might get a spec from like a HAR file or Fiddler, Postman, or even a burp scan. But all of these essentially need to be inventoried and tracked in order to be able to secure them and understand exactly what their context and their purpose is. But as we look at those Your question on where do you store these things? I've seen them obviously live in various formats, and some of them are not as flattering as API gateways. I've even seen them in some Excel sheets. But when we talk about another question, you said where can these things be stored or inventoried to keep track, but there are a ton of challenges and gaps that really revolve around precisely what you asked, and that is the inventory of these assets or these existing inventories of APIs. Dan, what are some gaps that you would say are plaguing majority of customers or users with regard to these inventories?
Yeah, so API gateways, central repositories, they're great. But if you, dear listener, are in an organization and thinking, oh, I wish that I had everything planned out such that all of my APIs were tracked, were well known and enumerated, you're in good company. I think that reality is often a little bit messy. If APIs are pipes, it's very hard to swap out a pipe that has active users from a lot of different places. So it's pretty natural to have not only a single API gateway, but some customers with whom I've spoken, I've asked them, well, what do you use? And they say, well, we use lots of things. We have a lot of different parts. It's the sprawl that kind of gets you. The unknown APIs that are out there are the ones that I would consider to be the ones that are really the riskiest. And that kind of speaks to the need for discovery, because APIs, they tend to be organic. They tend to be created to connect to business opportunities, and they don't always have a ton of oversight when they're deployed. Like a pipe, they get buried under the street and they do their job. People forget about it. I was recently on vacation. I'm a history buff, and I was walking on the walls of like a walled city. It was a castle that was attached to a city, and it was beautiful. It was really amazing, tiny little town. And I was struck about the planning, about how they had managed to encapsulate all of the town inside of the walls. But you can kind of see the sprawl of the medieval city, and then you notice right outside of the walls where there were additional buildings that had kind of been built, and they were in the same style. They were from the same time period, and they basically sprawled out beyond the walls. So even though you may start with a nice, beautiful castle and a nice walled city that has all of your APIs in one gateway, pretty soon you're going to overflow the bounds, and somebody's going to build outside the walls, and then somebody else is going to add on to it, and that's actually normal. It speaks to the need for discovery, and it speaks to the need for finding out and reconciling the official list with the list that comes from reality. That's one of the things that we're kind of building, is the ability to discover from real traffic. We've got a bit of tech that's coming out that allows you to take a Kubernetes cluster and load a daemon set, load kind of like a helper into it that is going to take a look at the traffic that is flowing on that network. It's kind of designed for taking a look at traffic that's right behind where you're terminating TLS. So we're going to look at the unencrypted HTTP traffic. But what we do is we build that map, and we allow you to survey what has been built beyond those castle walls so that you know where your threats are. So if, God forbid, somebody slipped into production, that big water main that happens to make the Galactus project work, by looking at traffic, you could find it. And you can say, oh, wow, you know what? We have these 6 sets of well-documented APIs. And then we've got this one that's doing 2 million queries per day that it's not on the map, but you can build that map. You can reconstruct that chart of all of the endpoints based on the traffic. You do a neat little bit of code where you kind of look at the TCP segments, you match them up into a stream, you extract it, you parse it out, and you can kind of say this unknown item now has a Swagger file that describes it. It now has an OpenAPI 3.0 spec that describes it. And that is suitable for feeding into a scanner, because as soon as you discover something that is unknown on the outside, you can actually point an automated tool and say, okay, so let's knock on the edges of this pipe. Let's make sure that it's solid. Let's make sure that it wasn't built with, an obvious beyond the walls way to get in and just ask, like our example that you led with, to be able to do something without any auth. So it's really, in closing, it's kind of the ones that you don't know about are the ones that get you. They're the ones that are the ones to be aware of. And Frank, I don't want to say that testing of APIs through DAS is the one way to do it. What are some other types of API security that one can get to get true defense in depth?
You hit the nail on the head there. The first one is you can't secure what you don't know exists. And even if you do know that it exists, you don't know to what extent or what capabilities it has. So really understanding, and again, first and foremost, is trying to get a good fingerprint or foothold into just exactly what your API's inventory looks like, right? What exactly are they allowed to do? Where are they? How can I secure them? So API inventory would be first in your kind of security in depth kind of defense. But when we look at also what goes into that, so we want to make sure, like if we're looking at in depth, what can happen? We look at this from a code and spec level. We want to make sure that the API has functionality that functions only within a spec. We want to make sure the API does not have capabilities that are not defined. We want to make sure that we're understanding exactly how that should function, what it should be allowed to talk to, what it shouldn't be allowed to talk to. We need to make sure that the code level understanding of that API also is secure. We can look at things, just as you would look at from a code base standing, right? We know that we have to scan the code that's written in there. We know that we have to actually do testing. As I mentioned earlier, a GraphQL endpoint with a SQL injection is going to be a problem, just as if you had a web application with a SQL injection. So that's where like the strength of the DAS scanner comes in, because we also, thoroughly test APIs for those type of vulnerabilities, whether it's a REST-based API, GraphQL, etc. But that's another area. Now, is that enough? I think the answer is always going to be no. We need different layers and different layers of protection. So there's things that can occur, let's say, post-deployment. We can have things like I mentioned earlier, those API gateways that have very concise constraints on what the API is allowed to do, how it is allowed to do that, maybe who has access, et cetera. So the API gateway is a perfect spot. We also have traditional web application firewalls that have some capabilities to block some of those attacks on the API, or even to be able to broker as a reverse proxy and do some analysis there. Now, we also have solutions that do full runtime protection on APIs. So if there's something that is being executed and the application or the API does not handle that accordingly, or it's being abused, it can automatically do a drop reset or whatever that is to make sure that that is not getting executed. And so, there's a lot of things that we can do in depth. I would say, first and foremost, just like apps, we're doing the discovery. We're looking at the code itself. We're making sure that the specs are stringent and being adhered to. And then we're putting in those various layers of protection on top of that. And one thing that we also need to understand is that just like applications, these APIs are changing and gaining functionality on a daily basis or multiple times a day. And then being able to make sure that we're not having things that get deployed that bypass your application security program best practices. So there's a lot of things that we can do there in layers. Maybe you can give us a walkthrough, Dan, of how does that actually occur? What is used to perform the scan? How does the scan occur from a dynamic scanning perspective when we look at an API from a spec?
Yeah, that's a great question, because it's we as users who use the web every single day, you can get a good idea that at a very, very high level, you can think of a DAS scan as just clicking through all the things, trying to open every single door, go through all the links, submit all the forms, and then find out all the little pins that jiggle and try to permute them until they pop, until you get a little bit of a cross-site scripting popping up inside of your browser. But APIs, unless you've kind of stared for hundreds of hours, as some of us have, at OpenAPI YAML files, it's a little harder to understand what they are, what they look like. So like I said before, they're kind of like the map. That map that you chart from either the original spec that the developer wrote, which of course is going to be complete and accurate and have everything, Or maybe the original spec that the developer wrote, augmented by traffic sniffing that shows the secret backdoor API that nobody forgot to put into the spec. But you're going to start with this specification. That is a YAML or a JSON file, and it effectively has an inventory of a list of operations and paths. Those are going to be paths that look like /users/ this. Usually they've got a prefix like /API /v1 to version it. But for each one of these paths, you're going to have kind of like a series of operations. If you Google Swagger UI, it kind of gives like almost the canonical way that programmers tend to think about what these things look like. But that list of operations and paths, that is given to the scan engine as an input. And each one of those operations will have a schema that defines what sort of input goes in and what sort of output comes out. What the scanner is going to do is take a look at that input, say it's a simple JSON document, and it's going to determine which of those keys can be injected into. So all the normal places that we would do attacks if we came across this API in the course of a normal web browse will do, but we'll also take a look and try to mutate things and create representative payloads that match the input that is being we want to match the input that is expected, because if you try to test an API and you just kind of like give it a little bit of like a low effort payload, what you can end up doing is not getting deep enough into the app on the other side. You just get back this 400 that says bad input, and usually the really juicy code happens a little bit deeper than that. So you usually want to get past input validation. You want to get to the point where you're querying that SQL table, where you're making that call out to the command line tool. So it's very, very important to get as proper looking inputs as you possibly can. Some things like cross-site scripting probably doesn't make sense, but it's totally legit to be able to steal an AWS identity token via SSRF from an API. Those sort of attacks, completely reasonable and completely valid to do.
Excellent. Thanks, Dan. We are just about out of time, and I hope everyone enjoyed this episode of AppSec Serialized on API security.
Thanks to everyone who contributed to this episode. Our opening fiction was written and voiced by Dan Murphy. Frank Catucci led our Q&A section. Zbigniew Fmana produced our episode and created our music and effects. Megan McBee was a buzz in the background providing marketing support. But thanks most of all to you, our listener. This has been another episode of AppSec Serialized.